My name is Ali Javi. I'm a professor of electrical engineering and computer sciences here at Berkeley. The big flavor of our research is bridging chemistry with electrical engineering. The goal of this project was to develop a wearable technology that we could use to get some accurate and meaningful information about the physiological state of an individual. Sweat provides us with a wealth of information about our body condition. It consists of a wide spectrum of different chemicals. But how do we get information that is accurate, useful about the body and health and mental conditions by analyzing sweat? We have developed these array of sensors that can detect and analyze multiple different chemicals simultaneously in real time.
And your glucose level is also normal?
And at the same time, we have developed the computation that goes along with it.
A microprocessor.
There is the flexible printed electronic component. This is where we have the sensors to detect the different chemicals in sweat. And then there's the second component, and that's where we can process the information, we can analyze the data, and we can also transmit the signal to a wireless, for example, wireless cell phone. Sweat is very complex, so we decided to target 4 different chemicals: sodium, potassium, glucose, and lactate. By looking at the concentration of some of the electrolytes like sodium and potassium, you can get information about dehydration. By looking at lactate, you can get information about muscle fatigue. So as your skin temperature changes, the output of the sensor changes. As part of this electronic board, we do have a processor chip, effectively a computer, that can simultaneously correct for this temperature change.
The board is working now?
So once we designed and fabricated and built our sensor, the question, of course, was what information can we obtain and how accurate it is. So we started trying to find collaborators on campus or off campus. Just one day in my office, I was Googling exercise physiology at Berkeley, and just like that, the first hit that I get is exercise physiology lab at Berkeley led by George Brooks.
It was really exciting to see somebody on campus taking an idea and measuring important metabolites in a body fluid in real time, in a transportable, miniaturized way. It's just fantastic. What we did was to have people exercise for different times, at different intensities, under different conditions. And we were able to show how well the device worked. A medical technician could get a reading on somebody instantaneously and then follow that, instead of taking a blood sample and then sending that to a laboratory and waiting several hours for a result. It's the beginning of, I think, of a great new realm in biosensing, not only for personal use, but for astronauts, people who need to be monitored for this or that condition in real time.
All the values are within the normal range?
Yes. I'm very excited about this work. This technology can be used in the future as a way of getting useful information about health in real time. And it's all done using a platform that is just on the back of the watch.